Hello, I'm Ankita Bharatdev, and I will be presenting on a presentation on topic impact of liquid cooling on 3D multiple processors. Let's start with the introduction. In recent times, 3D integration technology had become a boon and revolution in computer field. It also improved power and latency in modern circuits. But it uses multiple vertical layer of transistor and hence has low thermal conductivity and dissipation. It needs a proper cooling technique to reduce the power dissipation and reduction. Even in 2D processors, there is an issue for thermal management and hence we have thermal management resources. But 3D multi-core processors which are stacked have severe heat problems compared to the 2D processors as they have more power and less thermal dissipation, and this should be removed. Hence, liquid cooling is useful in reducing the high temperature problems of the processors and improve on performance degradation and reliability. The principle used in liquid cooling of CPUs is similar to the one used in automobiles' combustion engine, with water being circulated by a water pump through a block on the CPU. Liquid cooling also have an added advantage of less noise as compared to air cooling. Air cooling can become very noisy at times, whereas liquid cooling can sometimes go noise free, because of which computer applications give high performance. Hence, liquid cooling improves on performance degradation and reliability on energy 3D multi-core processors. Now we'll take a look at various liquid cooling techniques. Research in 3D integration technology have increased considerably to overcome the limitation of power and heat. It results in many challenges, including the heat challenge. Hence, a researcher illustrates in the microchannel liquid cooling to a 3D processor. This is called indirect liquid cooling technique. It's an active research area to use liquid microchannels to cool down high density electronics. The research on the liquid cooling system could remove heat at a very high rate, but the pressure drop is very large. Indirect liquid cooling technique it is explained as a dielectric liquid coolant is passed between layers which absorbs the heat from each layer. Now, in contradiction to the indirect liquid cooling technique, the water goes through layers in direct cooling technique. The liquid cooling reduces the temperature by 45 degrees Celsius as compared to the conventional air cooling technique. Let's look at the next research, which was proposed by as he proposed two methods as liquid joint flow rate and job scheduling. The liquid flow rate control is after analyzing the effect of each flow rate for 3D systems, they got to know which flow rate should be applied so that the temperature is guaranteed to cool below the target operating temperature. They set up a lookup table indexed with temperature values, and each line holds a flow rate value. They pick up the approximate flow rate from the table and then adjust the cooling system to meet the heat removal demand. The next method was job scheduling. The job scheduler of the authors is version of load balancing. To address the thermal asymmetries of course, they introduced weighted load balancing. Now, load balancing is used in many multi-core schedulers nowadays. A core's thermal behavior depends on where it is placed on the chip. They are assuming short threads, which is seen on server workloads. Hence, it uses a lot of threads for computing the job queue length of each core. They did not change the performance of the algorithm, but only modified the queue lengths as how they are computed. Thus, dynamic load balancing balances the workload by moving threads from a core's queue to another if the difference in queue length is above the threshold. Hence, these authors have achieved their goals of tuning the liquid flow rate to meet heat removal demand and minimizing the thermal imbalances across the chip to reduce negative effects on the reliability and performance. The challenges and contributions involved in the liquid cooling technique are these techniques keep the temperature level under control and below the threshold level. But in 3D processors, the heat or the temperature is very high compared to the 2D processors, and hence the conventional techniques used for 2D processors could not be used for the later. Now, one of the author proposed several DMT techniques that have been proposed to control the thermal management in 2D chips. But as I said, the heat or the temperature compared to 2D processors is very high in 3D processors. Hence, the conventional techniques cannot be used. In Another researcher named Congo proposed floor planning representation to reduce the maximum of on-chip temperature by 56%, and the proposed floor plan algorithm can reduce violence by 29%. This all was done to reduce the temperature and the total design time cost. But but as the research progressed and as the researchers now say that liquid cooling using water as a coolant is one of the good ways to reduce heat in 3D integrated processors since it has a very high heat capacity. Hence, there have been a lot of researches and since many years, and they have concluded that liquid cooling would using water as a coolant would be a very great way to reduce heat in 3D processors. Current steps for liquid cooling. IBM recently, in 2010, delivered a first of a kind hot water cooled supercomputer to the Zurich Federal Institute, marking a new era in the energy aware computing. They think it will be very helpful and can be a solution to the increasing amount of heat pumped out of chips as they become smaller and multi-core and more densely populated with components. They found out that stacking chips vertically will save critical space and enhance performance. Hence, they need interlayer cooling as heat is one of the major factors that plays role nowadays in small and populated chips in computers as the cores are increasing. To explain in simple terms, it happens due to the movement of electrons through tiny wires as on a modern processor. Water is much more efficient at absorbing heat and hence can show a significant result in heat and performance. Many companies and various researchers have put proposals for directly cooling chips with fluids. Uh, these are the references I've used for the topic. Thank you very much.